Hello and welcome back. The topics that I am going to discuss in this tutorial lecture are nodal analysis and one example based on the nodal analysis. So let us start with the nodal analysis. I have already discussed about the Kirchhoff law, Kirchhoff current law and Kirchhoff voltage law. Kirchhoff current law is basically used for the nodal analysis. Nodal analysis is used to determine the voltage at different nodes in the given network, given circuit. Now, after determination of node voltage, we can easily determine all the branch current. Nodal analysis is simple as compared to the mesh analysis. Now, let us start. Let us see which are the steps for nodal analysis of circuit. So, step 1 is what? Identify all the nodes in the given network and mark all the nodes and assign corresponding name, corresponding node voltage name, that is V1, V2, V3 and so on. So first task is identify the node and assigning the name to the node, that is node voltage name, that is V1, V2 and V3 and so on. Then mark all the branch current. Now in the mesh analysis, we have already discussed about the branch current and mesh current. Branch current in the mesh analysis, if one current is I1, current flowing in the other branch is I2, then current flowing in the third branch I have taken as I1 minus I2. There are limitation on the number of unknowns in the mesh analysis, but in the case of nodal analysis there is no limitation. If input current is I1, then output current we can take as a I2 and I3. So there is no limitation on number of unknowns in the case of nodal analysis. After marking the branch current, we have to apply KCL at each and every node, and we have to write the equation of the current in form of V, I and R, or conductance if the conductance are given. Now, after obtaining all the KCL equation, after converting the current equation in the ratio of V by R, convert those equations in the matrix form and solve them using Cramer's rule to obtain various node voltage. After node voltage is obtained, we can easily determine all the branch current. So these are the different steps which are going to be followed when we are doing the nodal analysis of the given example, given network. Nodal analysis, as I told you, is very easy as compared to the mesh analysis. There is no limitation on the number of unknowns. In the case of mesh analysis, there is limitation on the number of unknowns because based on the number of unknowns we will be having number of equation. Here there is no limitation on the number of unknowns. Now let us see one example based on nodal analysis. So here one network is given, one circuit is given, and you have been asked to determine the branch current. The value of the resistance are in ohm. The network consists of two batteries. Both batteries are having same voltage, that is 20 volt. Now in the nodal analysis, first step is to determine the node voltage. So first there are three nodes, 1, 2 and 3. So these are the three nodes. Now this node is a reference node, the node which is having a zero potential because all the branches are meeting here. And these are the two nodes in which we are interested. So now second step is assigning the node names. So suppose the voltages of these two nodes are V and VB. Now applying KVL in each and every node. So first assigning the branch current. So suppose current flowing into this node is I1. Suppose we are assuming the current is I1. Then current coming out is I2 and I3. As I told you, there is no limitation on number of unknowns. If we are taking this as I1, this is I2, then we can take this current as a I3. No need to take I1 minus I2. Now here one at VB, one battery is also connected 20 volt. So suppose we assume that current flowing is inside this node VB. So suppose this is I4, current at node VB, two currents are coming inside, that is I2 and I4. So one current will be going outside at node VB and that is nothing but the I5. So this is the second step. We have determined, we have assigned the branch current. Now you can take I4 in opposite direction also, but you will be getting a negative value of the current, but the magnitude will remain same. Now next step, step 1 is find V and VB. To find VA and VB, we have to apply KVL at node A and node B. So suppose applying KVL at node A. Now at node A, the incoming current is I1 and outgoing current is I2 and I3. So we can write I1 is equal to I2 plus I3. Now converting I in terms of voltage and resistance. So we can write I is equal to V by R. Now I1 is flowing from 20 volt battery to VA node, and current flows from higher potential to the lower potential. So we can write 20 minus VA divided by the value of the resistance, that is 1. So I1 is equal to 20 minus VA divided by 1. Now I2 is flowing from A to B node, that is flowing from VA to VB, and the resistance is 0.5. So we can write I2 is equal to VA minus VB divided by 0.5. And the third current is I3. I3 is flowing from VA to 0 potential voltage. So we can write VA minus 0 divided by the value of the resistance, that is 1. So this is how you can convert the current equation in terms of V and R. The point to be remembered here is that, point to be noted here is that you have to consider the direction of current flowing, and according to that you have to write the equation of V, equation of V and R. Now if we solve this equation, we will be getting 20 minus VA is equal to 2 VA minus VB plus VA. And if we finally solve this, we are getting 2 VA minus VB is equal to 10, and assigning this as a equation number 1. Now how many equation we will be getting? So equation in nodal analysis depends on the number of nodes. Here there are 2 nodes. We will be having 2 equations, so 2 unknowns will be there. Now applying KVL at node B. Now at node B, incoming current are I2 and I4, and outgoing current is I5. So we can write I2 plus I4 is equal to I5. Now converting I2, I4 and I5 in terms of V and R. Now I2 is flowing from VA to VB, so we can write VA minus VB divided by 0.5. I4 is flowing from 20 volt battery to VB, so we can write 20 minus VB divided by 1. And I5 is flowing from VB to 0 potential, so we can write VB minus 0 divided by 2. So this is the equation which we are getting after converting current in terms of voltage and resistance. If we solve this, we will be getting 2 VA minus 3.5 VB is equal to minus 20, and this is nothing but the equation number 2, and this is equation number 1. If we solve this equation by method of elimination or any method, we can get the value of VA is equal to 11 volt and the value of VB is equal to 12 volt. Now, we have been asked to determine the branch current. So I1, I2, I3, I4 and I4 we have to determine. Now I1 is flowing from 20 to VA, so we can write I1 is equal to 20 minus VA divided by 1. So value of VA is 11, so 20 minus 11 divided by 1, that is 9 ampere. So I1 is 9 ampere. I2 is flowing from VA to VB, so we can write VA minus VB divided the value of the resistance, that is 0.5. If we solve this, we will be getting minus 2 ampere. I3 is flowing from VA to 0 potential, so it will be VA minus 0 divided by the value of the resistance, that is 1. So 11 minus 0 divided by 1 is equal to 11 ampere. I4 is flowing from 20 volt to VB, so 20 minus VB divided by 1, so 20 minus 12 divided by 1, that is 8 ampere. And I5 is flowing from VB to 0 potential, so VB minus 0 divided by 2, so 12 divided by 2 is equal to 6 ampere. Now, how we can verify the answer which we are getting, the answer are correct or not? So at node A, I1 is equal to I2 plus I3. So I1 is 9 ampere and I2 and I3 is minus 2 and 11. So sum of these two will be 9 ampere. So the answer which we are getting at node A, I1, I2 and I3 are correct one. Similarly, I2 and I4, summation of I2 and I4 is 6 ampere, and that is nothing but the I5. So the answer which we have got are the correct one. So in this video lecture, I have discussed about nodal analysis, one example based on nodal analysis, which are the steps to remember whenever we are doing the nodal analysis. Hope you have enjoyed the videos. Thank you for watching.